In this last little video, what we're going to do is try to find the coordinates for the points on a circle whose radius isn't equal to 1. So what we have to do is we have to have a small version of the unit circle. So here's our little unit circle. And we've got to have a much bigger circle. It can be smaller, but the calculation is exactly the same. So we'll just draw it bigger. And hopefully, I won't draw too bad of a picture. And we have to have our axes in there. Here's the y-axis. Here's the x-axis. We're picking a point on the bigger circle, and we want to find the coordinates for that if we happen to know theta. So what we're going to do is we're going to draw the radius. We're going to draw the two reference triangles, the big one, ta-da, and the little one, ta-da. And what we're going to do is start labeling points. First off, the angle for both triangles is theta, like that. This little radius here is 1. The big radius here is something bigger than 1, and we're just going to call that r. Now what am I going to do? I am going to call the x-coordinate of the big circle way up to here. That's going to be x. The height here, I'm going to call that y. And I do need the coordinates of this point on the unit circle. Now, you'd think I'd call that little x or little y, but you know, we already have names for them. If I want this point right here, watch what we do, right? What did we do? We started with the unit circle, we went here, and we went forward angle theta. What do we call the x-coordinate when we do all that? Well, that's the x-coordinate there is just called the cosine of theta. And the y-coordinate there is just called the sine of theta, like that. Now what we're going to do is use similar triangles. So what I have is, for example, I have the little x-coordinate here over the hypotenuse is equal to the big x-coordinate over the hypotenuse. We'll write that way up here. The little x-coordinate, that's just cosine of theta over the little hypotenuse, well that's just 1, is equal to the big x-coordinate, which we don't know, over the big radius, which is what they told us. And so what we're going to get there is that the x-coordinate there is r cosine theta, like that. I'm now going to try to find the y value. How am I going to find the y value? I'm going to say the little vertical over here over the little hypotenuse is equal to the big vertical here over the big hypotenuse. The little vertical right here is the y-coordinate of that little triangle. Well, that's just sine theta. So I'm going to get the sine of theta. That's the y-coordinate over the little hypotenuse is equal to the big y-coordinate, which we don't know, over the big hypotenuse, which is r. So what we're going to get is y equals r sine theta. I'm going to put these in little boxes. So those are the formulas for the x-coordinate on a circle of radius r and the y-coordinate of a circle of radius r. You might not know, but this is actually different coordinates for our plane. They're called polar coordinates, and they were invented by Isaac Newton when he was trying to solve some calculus problems. So these are very famous, they're very, very useful, and they just got thrown in as a postscript to this section. Ta-da!